Okay, hello, this is attempt number 3 to record the video, hence the reason it is going to be posted so late. Sorry about that. Bad things happened. Key things we're going to go through in this video for the review: interval and set notation, some solving stuff with those absolute values, both with just equal signs and inequalities, and then we'll go through a little bit with that graphing, and included in that we'll go over some domain and range. Okay, so interval and set notation, this is, hold on. Okay, sorry, okay, now we can see it right away. So, interval notation, that is real blurry. Interval notation. Okay, so interval notation here, we have a couple ways we can look at it. We can do it with our parentheses, a comma b. It looks kind of like a point, but it's saying any value between a to b. So we can write that in an inequality as well. And that would just like a is my lowest value, so a is less than x, which is less than b, because it's always going to be lowest, comma highest. So if you need that reminder, I'd recommend writing that down. This is lowest and highest. Now, if I were to try and make this inequality set builder notation though, set builder, all I have to do is add the notation around this inequality that I already wrote. It looks like a brace x, and then a bar here, and then an end brace. So lastly, we can draw these on a number line. On our number line, it just looks like those values between a and b, and these would be open holes because we're not including them here. That's what our parentheses mean, and that's why it's just less than symbols. Now, in order to include them, we would just use brackets instead. A comma b with brackets. This inequality would look the same, except for it would have the or equal to symbol now. A to b. If I make that set builder, I just do that brace x bar in the front, end brace, and finally on that number line, it's the exact same thing, but I can do closed holes. And we can mix and match this in any way that we want. Now, what we can also do with these is have these go off to infinity. So we could have it go from a up to a positive infinity, and we always use a parenthesis on infinity because I can't ever equal it. It's not technically a number, it's a concept. So here, what that would look like, our brace x bar, that inequality is just saying, hey, x is always greater than a or equal to it. Because I see that bracket, I need to think or equal to. End brace. So on a number line, what I need to do is I need to think, okay, well, I'm at a. And because it's greater than tells me I'm going to larger values, so that means I'm moving off to the right. Next, for a negative infinity, I could start at negative infinity. Oh, and this should be a closed hole, sorry, because that was a bracket. And I could go up until a, say that was a parenthesis, we can mix and match, remember? So brace x bar, a is less than, what am I thinking? Sorry. Brace x bar, we know that this is going to the left, so x is less than a this time. End brace. So what that will look like on a number line here, we'll be at a, we'll have an open hole this time because it's a parenthesis, but now we're going towards negative infinity because we want to go towards our negative numbers. So that's our interval and set builder notation. We'll use these mostly to represent those domains and ranges, which we'll look at when we get to our graphs. Now, for solving, sorry, let me pull up my notes. Our first step for solving is always to take it and make sure our absolute value is isolated. So if we had something that looked like a 2x plus 3 inside an absolute value, minus 3 is equal to 2. Well, what I need to do, that first step, is just to isolate that absolute value. So that's going to be this portion right here. So I'm going to look at that operation, say, okay, this is something minus 3 equals 2. Well, this is what I want by itself, so I need to get rid of the minus 3. Add it to both sides. Remember what we do on one side, we have to do on the other, so this will cancel out. Be really careful. This whole thing comes down. So I see a lot of people changing things when they rewrite them down below. Nothing needs to change. Just rewrite it. On the right side, we'll end up with a 5. Now from here, I've isolated it. My second thing is to check for negative values, because if it were negative, it would be no solution. But if not, I move on to step 3, which is setting up our related equations. Oh, my pizza's ready. Equations. Oh, I said that out loud. It's fine. Okay, so first equation, nothing changes. All we do is get rid of those absolute value bars. So it should look like a 2x plus 3 is equal to 5. Then for my second equation, 2x plus 3, but instead of 5, we take that right side of our equation and we multiply it by a negative 1. Negative 5. So when we do that from here, we're just solving. We always ask ourselves, what do we get rid of and how do we do it? So if I want x by itself, I need to get rid of the 2 and the 3. Well, how I do that is I get rid of the 3 first because it's addition and subtraction. Subtract it on both sides. This will cancel. 2x is equal to 2. Last thing is that division, divide by 2, divide by 2. This will cancel. And x is equal to 1. Oh, my cursor's on the screen. Alright, and for 2, same steps, subtract 3 on both sides. This will cancel. 2x is equal to a negative 8, so x equals a negative 4, because I'll divide by that 2 on both sides. Okay, now that we have our two solutions, our last thing would be to check our answers and then plot them. So check and plot. Whenever we check our answers with not inequalities, what I'm looking for, absolute values, we plug them into our original equation way back up here. So if I were to plug 1 in, it would look like a 2 times 1 plus 3 minus 3 is equal to 2. Well, that will get me the absolute value of 5 minus 3, which checks out. When I plug in negative 4, we'll end up with a negative 8, because I'll have 2 times negative 4, plus 3. Minus 3 is equal to 2. Well, this will get me at the absolute value of negative 5, so once again, we'll be at 5 minus 3 equals 2, which checks out. So last thing would be plotting these. We will have a negative 4 and 1, and they're just going to be 2 solid points on that number line. Okay, so take a second, get this down if you need, pause if I went a little too fast there, and then we are going to go into some inequalities now. Okay. So for inequalities, the key things with them is to remember that negatives aren't necessarily going to be no solution this time. We have to be more careful with them. But there's still a red flag. So say I had something like the absolute value of a 2x minus 3 still on that inside, plus 2 is equal to, or sorry, not equal to, less than or equal to a negative 5. Well, what I would do here is my first thing is to isolate. So what I'm going to do is I want this by itself. I see a plus 2. I'm going to subtract that on the other side. This will cancel. Bring everything down over here at 2x minus 3. Oh my god. There we go. 3 less than or equal to a negative 7. Now that we're here, it's isolated. My second thing is to now check for negatives, for negative numbers, because that's going to be a red flag. So this time we don't necessarily know what it means right away, but we know that something is going wrong. And so when I see this inequality with less than here, this negative value, well, the types of numbers I'm getting out of absolute value are always greater than 0. So we're always getting positive numbers out of that absolute value. And so we're saying positive numbers are going to be less than a negative 7. So in this case, if I have my absolute value less than a negative number, we'll have no solution. So I can stop here, I don't need to go farther forward. But now let's say we had that absolute value of a 2x minus 3 plus 2 is greater than or equal to a negative 5. Well, once again, isolating, step number 1, subtract that 2 on both sides. We'll end up with that absolute value of a 2x minus 3. But now it says greater than or equal to negative 5. So once again, I'm saying check for negatives. It's a red flag. It means something strange is going to happen. But this time it's saying, hey, this positive value that's coming out is going to be greater than a negative number. Well, positive numbers will always be larger than negative numbers because that's how our numbers work. We have 0, negatives are over here, positives are over here, so these are larger values than our negatives. So this one is always true. So what's going to happen is x is all real numbers. Or if we wrote that in our interval notation, negative infinity to infinity. Now we'll do one where we can actually solve all the way through so we can look at what those steps would look like. So let's say we had, we'll just keep that same equation, but we'll change it. So 2x minus 3 plus 2, but this time let's say it's greater than 7. So if we have this new equation here, we're going to go ahead, first step is to isolate still, doesn't change. Subtract the 2 on both sides. This will cancel. 2x minus 3 comes down, keeping those absolute value bars, greater than 5. Now, second step, checking for negatives. Well, we don't see any, so we can go forward to step 3, because this was positive. And we're going to say, okay, we want our compound inequalities. Now, this is a new word, but it's exactly like our related equations. We're just going to take this 5 and leave everything the same, and then on one of them, we'll multiply this side by a negative. Now, one other thing will happen there because of that, and we'll talk about that in just a second. So here, that 2x minus 3 won't change. Greater than 5, I have one equation I can solve now. For my second compound inequality, that 2x minus 3 won't change. We just drop those absolute value bars. But the 5, well, I'm multiplying it by a negative 1. And when I multiply by a negative 1, or a negative in general with inequalities, we have to flip the sign. So this greater than, well, it's going to switch to a less than. So now, when I solve this, add 3 on both sides. This will cancel here. 2x is greater than 8. Divide by 2 on both sides. X is going to be greater than 4. Over here, we're adding 3 on both sides. We're going to end up with 2x is less than negative 2, so x is less than 1. Sorry, negative 1. So now, step 4 would be to check and plot these answers. Check and plot. I trust you guys be able to plug those in. When you plug them in, these will check out for us. So when we plot this, we'll be at negative 1 and 4. Well, at negative 1, it said it was less than it, so I'm going out to the left. That goes this way here. And at 4, it says it's greater than, so it's going out to the right. That goes this direction here. So there's actually only a small portion here where our x value would not get a value. That was not greater than 7. Okay, that is the last little bit for our solving. I'm going to do a quick thing on graphs, and then I'm going to call it good because this is the third time I have recorded this video, and I'm getting very tired. So, for graphing, the key thing is we can go between a lot of our stuff with graphing. So I could be at graphing, but it could also be related to me using an equation. Or it could be saying, hey, you're going to create a description of this from your graph. Or it could say, okay, you have an equation, you're going to graph it. or we have a description. We're going to graph it. And the reason this is all helpful to make sure we know is because then we can also do the portion where we go from descriptions to equations or equations to descriptions. So these all work together in tandem. It's all the same exact rules for all three of these. So if I were to say, we'll start out, let's say they gave you an equation. And they say, well, you have 2, the absolute value of x minus 3 plus 1. This is our function, this is f of x. Well, let's say they want us to go from an equation to a graph. There's some important information we need in order to do that. We want out. So the two things we need our vertex and we need our slope. And both of those we can get from our equation. So our vertex is our h comma k value. And be careful, remember, our h value is always going to switch because it says this is an x minus h, so these negatives would be canceling out here if our h was negative. But it's still here, so that means this minus 3, I actually have a positive h value. So whenever we see a minus in our equation, when you think, okay, this h is the opposite sign, so this is going to be a positive 3 for h. And our k value, it'll just stay the same because it's a plus k. So if k is going to stay the same here, it's going to be a positive 1 for that. Now our slope is just that a value way out in the front. It's very similar to mx plus b, except for our b is now two different things here, h and k. So m times our function, well, in this case it's a now. So a is equal to 2, which tells me my slope. When this is positive, it opens up. So what I'm going to do is I'm going to go to the right 3 and up 1, put my point. To find my next points in order to graph this, I need to think about that slope. 2, it's rise over run. So another way to think about 2 is a 2 over 1. So in this case, we're here, we're going to go up 2, to the right 1. Boom, so we're just going 1, 2, and then over 1. I now have the right side. Sorry, I'm dying. Okay, up 2 to the right 1. Now, for the other side of my graph, it's the same thing. I'm going up 2 and then to the left 1. So up 2, left 1 instead. This will get me the other side of my graph. Another way to think about that is these are symmetrical graphs. So if I found this side over here, it's just going to reflect and be on the other side. Okay. Now, last thing would be that description part. And that description part comes from our vertex and our slope as well. So that h and k value, these tell us how we moved, left, right, up, or down. And our slope tells us what our stretches and shrinks look like. So if I have this, I'm going to look at my equation. I'm just going to work my way left to right. If I were to make a description of this now, I would say, okay, well, farthest left I see 2, multiplication. Whenever I see multiplication, I need to think stretch or shrink. But I need to decide which one it's affecting, vertical or horizontal. Because it is outside of my absolute values, it's always going to be a vertical effect in that case. Now I need to decide between stretch or shrink. Well, when it's a number greater than 1 for verticals, that's going to be our stretch. And then we would say, okay, well, this was by a factor, and we would just list the number that we saw there as our slope. By a factor of 2. So our slope tells us how we stretched our graphs. How far up did we pull it? Well, we did it by 2. Now here I see x minus 3. Whenever I see that addition and subtraction, I'm thinking translation. So this here was our stretch. So, minus 3, okay, well, my h value though switches sign. It was on the inside here. Also, when it's on the inside, it's no longer a vertical effect, it's going to be a horizontal. And we already said that this is a translation. Translation. Now we just need to decide left or right. So up here, we already decided that this was positive, so we would say, okay, this is a translation, right, 3 units. Now say on your test you had panicked and you forgot to switch the sign on your H value and you would put a -3 here, you would just say to the left 3 units. And you probably would have graphed this on the other side then. You would have gotten follow-through points here. So here you would have gotten marked off for your vertex, but down here you would still earn a point for your description as long as it matched your graph. Now for this translation, this plus k value, well, plus k, that's still addition and subtraction, that's still going to be a translation here, but now it's on the outside, it's no longer horizontal, it's going to be a vertical translation. If I'm doing a vertical translation, that means it's either going up or down. If it's a positive value, it's going to go where I expect it to. It's going to go upwards by 1 unit. So that is the last of that for our graphing. The only other thing we ask about with our graphs is that domain and range. Now, domain for absolute values won't change. It's always at all real numbers or -infinity to infinity in interval notation. But it could also change. So we saw an example of that on our quiz. So we'll look at one quick example for that in a second. And then range, it is always your k value up to infinity. So if you can find your k value, this 1, you know your range. This is for if it opens upwards. Now, if it opens downwards, -infinity up until k. Oh, cat. Hi. I'm being attacked. So this opens downwards, and that will give us our range. So in this case, we know we're opening upwards, and we know our k value is 1. So our range would just look like it goes from 1 up until infinity. All right, there's only one other thing with that domain and range, and that is if I had a graph where it were restricted. So we saw an example of that on our quiz, and we saw it again in our free response today when we did our practice. So let's say this is at positive 2 here, and at 3, and say this is at -1, -2. Well, what we need to do to find this domain and range then is we need to say, okay, well, these are x values, so I need to look at this and say, well, what is the x value farthest to the left? Well, farthest to the left on my graph that I can get to is at -2. -2. And this is an open hole here, so I'm using a parenthesis. Comma, this next one, sorry, that was supposed to be a closed hole, is a closed hole. And I'm saying, okay, well, that's as far as I can get to the right on my graph. Domain is an x value, so I'm going, okay, how far to the right could I go? I'm tracing it over, and then I'm saying, well, what was the x value here? +2. Now for your range, you're tracing your graph. You're not necessarily going left and right. You're saying, okay, well, what's the lowest value I can get to on my graph? Well, the lowest value I can get to is over here. Remember, our y values are on this line here. Don't get tricked, though, by saying, oh, it's at a -1/2 here. It's not looking at intersections, and it's not looking at the x value. You're looking over at that y value here. So you're saying, what's the lowest point? Okay, well, that y value is at -1. Oh, this should be a bracket, sorry. Bracket, because it's a closed hole here. Now my highest value, I'm following that. Oh, this is at my closed hole. And once again, I'm looking at a y value this time. It goes all the way up until 3. So that would be our domain and range for that situation there. There was one last little thing that I almost forgot to do, and that is going ahead and being able to write our equations to represent different real-life situations. So let's say, I think it was the example in our notes packet or the review packet that you guys got was like miles on a car trip or something that you were going, and you at minimum wanted to go like 300 something, so let's just say 300, and at maximum you wanted to go 500 miles. So like, what is an inequality that represents the number of miles you would be willing to travel? Well, these would be closed holes because I'm willing to go 300, or I'm willing to go 500, or anywhere in between. So this would be an inequality representing it, but we want to have an absolute value that represents it. So what that would look like is we need to find our middle number and our distance. So the middle value between 3 and 500 is going to be a 400. So then our distance is a 100. So these are our B and our D values. So we have this equation in our notes if we remember. It says it's going to be x minus that B value. And now it's going to either be greater than or less than here. Well, I always want it to be less than this distance, because if it's greater than this distance, I'm going to go off over into this direction to values larger than 500, but I don't want it to be more than this, so it's going to be less than that D value. So in this case, what it would look like is an x minus 400 is less than 100. So the reason this works out is because let's say, oh, well, I want to travel 450 miles. If I plug 450 in here, minus 400, less than 100, well, does that check out? Is that a solution? Yeah, that's a distance we could drive because it's saying, well, 50 is less than 100, which checks out. All right. So I think that's pretty much it. If you still have questions, if we are in school tomorrow, you can see me if it's before the test, or you can send me emails. I will probably not respond tonight, though. It probably wouldn't be until the morning. Sorry. Have a good night.